Well, thank you. What a pleasure to be here. I'm going to spend the main part of my talk talking about the very early days that, in some sense, preceded the 72 demo and preceded even the DARPA effort. So, as Raj said, I was a grad student at Stanford, had finished all my courses in my qualifyings, and suddenly this guy who I had linked up with to do my dissertation work with suddenly went from Stanford to CMU, and he said, "Oh, come, you'll be out in 6 months." But that turned out to be one of the best moves that I ever made in my life. For one thing, because of the environment at CMU, because of Simon Newell and Perlis, and the community of cooperative researchers. One of the things that they did is, I believe, is they took all the money that each of the professors got, all of the grants, and they decided how to parcel it out to the entire department, and insisting that people collaborate across projects and things like that. It was phenomenal. Everybody went to everyone else's seminars. Everyone knew what they were doing. CMU created the notion of Black Fridays, where every grad student was reviewed, not to be disciplinary, but on the contrary, to support them. And so it was wonderful, wonderful time. And I think CMU is still very much the same way because of people like Raj continuing that tradition. And all right, so I arrived, I think, in February of 1970 to CMU, and I was a, quote, terminal grad student at Stanford, and hired actually as a researcher at CMU, which was a pretty good deal. But I arrived there, and Raj said, "Okay, we're going to build a speech understanding system." Again, this was in 1970, before the Newell report even got started, I think, or maybe it was just beginning to get started.
That's how it got the name.
Yeah. And Raj handed me this diagram. And if I dug this out of a box in my garage a couple weeks ago, and if you look in the upper right corner, you can kind of make out already March 1970. And he said, "Okay, here's what we're going to build." And I looked at this thing, and I knew a few things. I had known enough about speech that I had done with Raj at Stanford to know the variability in the problem we were being faced with. Not only, multi-speakers, but the same speaker from moment to moment. And I also knew that every one of these, let me call them knowledge sources, all of these rectangular boxes were going to be errorful, and the speech signal that they'd be working on, everything would be errorful and variable. And I also knew that over the course of trying to build this thing, we were going to have to experiment and constantly change things, both in the individual boxes, but even more how they were interacting. And I looked at this and I said, I have no idea how to build something that we can control the interactions with these and evolve it over time, especially with multiple people working on it. So one of the things you'll notice is there are several boxes here that have curly braces that are called symbolic utterance description, SUDs. Partially partitioned SUDs, critical segments, and so forth. And it seemed to me that that would be a very generalized notion of what this symbolic utterance would be the way that these things could communicate with each other. And so I'm, as Rick Hayes-Roth mentioned yesterday, I'm a simple guy. And so to simplify things, I said, okay, let's make all of these things be totally separate from each other, having no notion of how they're interacting with each other, except through what this SUD is. And of course, Raj never defined what this was, other than it's a symbolic utterance description. So I started working on this, and essentially I came up with the idea of, again, a very simple idea of saying, okay, let's have a description and have each of these, and we call them knowledge sources, be totally separate and anonymous from each other. And they would both compete in some sense because each would be errorful, and one would say, oh, I think it's this, and someone else would say, no, I think it's that. But also cooperate to come up with some interpretation of what the utterance was. So that, and I'm not sure where we got the name Blackboard, but I know it was created actually and used like a decade earlier by a number of people. I have no idea. I don't claim that I came up with the term Blackboard. Probably Raj or maybe Simon suggested it, maybe saying, oh, well, that looks like the Blackboard architecture. And we said, oh, that really fits well. One thing I would like to, again, in a historical document, even more striking than this one, also turned up. And so here we have the user, who is over here, being covered in suds. And there's this, one of the knowledge sources is the hum and har. And well, here we had the user at the console, and here we have the consoler. And based on actually, I was trying to figure out who made this document, this cartoon. And somehow I thought it was Vint. But Vint said no, he was never around. And when, based on Steve's presentation this morning, I said, it was Lick. It was Licklider.
That makes sense.
And probably in 1970, he wandered through there, maybe working on forming the Newell Task Force. And we probably made a presentation to him because we were still at this stage. Because anything much later than that, we would never have used this. So that must have been Lick. So I also found this in the same box that I found the other thing. So I'm going to technically focus on one aspect of the work that we did, not just for Hearsay, but within the whole speech work at CMU at that time that also helped support Dragon and Harpy, which is the environment that we built, the whole software engineering and hardware engineering environment that we did that made it possible for us to be able to evolve all of those systems, Hearsay, Hearsay 2, Dragon, Harpy, over a number of years. And actually, if you read Dennis Klatt's review of the entire DARPA program, which is highly in depth, and I commend it to you, it's quite a work of art. One of the things that he said that made CMU successful is that we paid attention to the kind of system and software engineering aspects so that we could continue to evolve things, including, like the ability, as Steve mentioned, working up to the 6-month demo in June of 1972, but also quite a bit beyond that, including the last 6 months of the program where Hearsay 2 was, let's say, not functioning quite as well as we would have wanted.
I call it failing catastrophically.
Failing, well, okay. And one of the things we did, besides, of course, getting into all of us working on the project, and several of them are here, Rick and Vic, and at that time also Mark and Jack, Mark Fox and Jack Mostow and Vic Lesser and Rick Hayes Roth. We, as a community working together, we pledged that we would work 7 days a week, and we had to ask permission of all the others if we wanted to take a day off for those last 6 months. And one of the things we were able to do, because we had the infrastructure to be able to make drastic changes quickly and still have the system functioning, even though pieces of it were being programmed totally separately by other people, but this went through the whole program. And that's something that I'm very proud of, because I was the kind of the originator of saying how we're going to lay this out, again, very early on in 1970 and then over 71. And along with, I do want to give credit to Rich Neely, who's not here. He was my partner in setting all that up. So we knew we were going to have individual knowledge sources that are going to be programmed by different people, and they're going to have to evolve. And at times new ones would come in and old ones would leave. We knew we had to be able to have control of their interactions, how they access the blackboard, the SUDs, if you will. And we knew we would need a large, in those days, large database of speech examples for training and testing. And all of this in the context of having very, very meager computing resources. The KA-10 we were on was 0.4 MIPS. And I don't remember exactly what the memory was, but the watch on your wrist was probably 1,000 times more.
I think we had a million bytes, 1 megabyte, but it was words. It was
yes, yeah.
It was that
and also
bits, or I don't know what.
And also for the speech data, we had the big washing machine multi disk things, and one of the things that we also had hardware that we created in the lab there for being able to do A to D and D to A and the zero crossing, and we actually had a thing where we could control it from the computer to set up exactly what the switches were and what filters, because otherwise if you had to go do those things manually, it would be, you couldn't recreate things. And so what we did is we built a whole then software infrastructure for how to even have different knowledge sources compiled separately with version control. So when you created a system with 47 components, did they match? And we did things like we built added to the computer a 10 microsecond clock, but boy was that fast, as opposed to Jiffy's 60th of a second, so that we could time all of the software and figure out where the bottlenecks are. And I remember one Christmas vacation, Vic Lesser and I sat down and we totally, based on the tests we had done, re-implemented the fundamentals of the system. People came back, ran their knowledge sources, and now things were running, I think, like 8 times faster. And they didn't notice any difference in terms of what their programs were. So the software and hardware infrastructure, and then we also had displays. The lab there was working on graphical displays that at that time were cutting edge. Raj went to Bell Labs and came back with a long distance xerography machine that turned, and then we built it, the lab there built an interface. Vic Lesser wrote some software for it that we could then use to print out waveforms and, variable width fonts for documents, which was cutting edge at that time. In fact, we created the fonts by Raj came back with these card decks from IBM with some crazy internal language for splines for fonts. Wow. And I remember I reverse engineered just from the card decks because I had no documentation. Reverse engineered to make dot matrix fonts from those, and they were very nice. So this was a lot of the work that we did. So I'm going to, then we did have this crazy thing. I thought it was a year, but I guess it was only 6 months that
Felt like a year.
So this is oops. There we go. The third document that I dug up. This is a memo from Alan Newell on June 9th, 1972, to Bill Broadley, who was the head of the hardware lab, to me, to Rick Fennell, who was another one of the researchers who we were working with, Phil Carlton, who was one of our programmers, a grad student programmer, Don McCracken, who was kind of one of the software engineers who helped. One of the things we did is we imported the SAIL programming language from Stanford, because trying to do this in Lisp or something we knew computationally would not work. And SAIL actually turned out to be fabulous for this, including that you could drop in assembly language right in the text. It had a fabulous macro facility that allowed us to do a lot of flexibilities at compile time, whether we wanted to compile in like access to the timing to the 10 microsecond clock. Rich Neely, who I mentioned before, Paul.
The macros allowed us to build a layered architecture,
Yes, yeah.
which allowed us to do this type of implementation that we did,
Right.
where we just pulled it out of the out.
Right, we could make significant changes ubiquitously through all of the modules using that facility. Paul Newberry, who's also on the hardware end, this guy Raj Reddy, and George Robertson, who is also a software engineer who helped do some of the work. So I actually want to kind of read this. That was an absolutely superb demonstration that you put on Wednesday. So now I could figure out what day the demo was because I had no recollection. So I think that was then June 3rd. I think it's hard to overestimate the impact of the total performance on the assembled group, of the actual speech system performance, the demonstration setup, which Steve was mentioning, and the set of display and rummaging mechanisms, which was also something that we built in at the very beginning, so that each person writing a knowledge source had access to ways that they could do interrupts and dump things in very convenient ways, again, and using a kind of a macro language for doing that, so they didn't have to create that for their individual knowledge sources. And then every time we improved those, everybody could make use of them. Rummaging mechanisms, responsiveness and availability of the system. So I vaguely remember that we actually did a bunch of real-time stuff as well as the canned stuff. And actually there's a story behind that, but I won't go into. And especially fine was the scientific openness of the day, in which the goal was to expose all the mechanisms, as much the ones that didn't work as the ones that did. And Newell's conclusion was this was an event of scientific significance of what had happened. And that was just the start.
What was rummaging?
Well, you could rummage through, what was happening inside the system.
Debugging.
Well, not just debugging, but also evaluating what was happening. Why did it go off in this direction there and not there? Or if you just wanted to gather statistics. Do I have about 2 more minutes?
Sure.
Okay. So I just want to totally shift. And what you're going to hear today is nothing like else you're going to hear today. Nothing anyone else is going to say. One thing is that I created the simplified thing, which was the only way I knew how to start this thing. And then a few years later began to understand or learn that neuroscience was coming up with somewhat of a similar model for what was going on at a macro level in the brain. I mean, I knew about Hebbian neural nets and things like that, but I didn't understand the macro structures in the brain, that actually in the brain there were these different centers that were both competing and cooperating for the functioning of the human. Now there are a lot of differences that have come out, but I thought, to me, that was interesting. So I left CMU, I went to USC ISI, then I went to this startup company when this guy, Rick Hayes Roth, called me and said, would you like to join us at Technology? And I was there for quite a while. And then I began a hobby of massage therapy, which slowly turned into an avocation, which slowly turned into ramping up, this is a career, and ramping down on my computer science. So by around 2000, I was pretty much out of computer science and into massage therapy, totally specializing in working with inpatients at Children's Hospital, Adult Hospital, and a VA inpatient hospice. And this became, until a pandemic, is what I had been doing. The hearsay experience actually very much informed that work. because of learning about the incredible variability both across individuals and even the same person from one day to the next. And it really was fundamental to the work that I have been doing then for the last 25 years. I also was able to function as the computer guru for all of the massage therapy groups that I was in. And so that was fun to be able to keep my hand in. Another thing that where the hearsay and the speech work at CMU has really impacted my life. I mentioned, and Rick had mentioned yesterday when we were talking, that about a collaborative group of people working egolessly on a joint project where we're all committed and a challenging project over a long period of time. So starting in 2009, I joined a group starting a co-housing community in Mountain View, where we bought a piece of land, designed, developed, built a community, and have now been living in there since 2015. And one of the things that attracted me to that from the first day that I became acquainted with some of the people was seeing that this is a similar kind of thing of people, very smart people, working on a really difficult problem. And boy, we can tell you about the problems we had. And that also desiring to recreate that same kind of environment that I experienced at Carnegie Mellon in the early 70s.
Right there.